Thank you so much. Thanks so much for inviting me. Really happy to be here. I'm going to move until maybe most people can see me okay. And then thank you so much. So I thought I would talk a little bit today about a topic that I've been thinking about, which is what is the role of sort of science and scientific principles in thinking in applied data science? So I'm sort of stuffing a couple of things into that framework. This is the first time I'm giving this talk, so you guys can ask questions and give me feedback if it makes sense or not. So I like to use a lot of pictures and cartoons. I am a visual thinker and I get bored really quickly. And I like this cartoon as an example of sort of the challenges for data science in industry or in business. This is so accurate. I don't know how many of you work in industry, but these are what your boss thinks data science is, right? Money printer, or we used to say money cannon. Literally, we would say that on past jobs I worked in. It's not. What my customers think it is, right, which is a magic hat out of which I will pull, I guess, still money, right, or answers or insights. Software engineers in the room, no offense, what software engineers think data science is, some software engineers come in with a sort of scientific mindset of thinking, depending on what type of training they've had, and some don't. So they do sometimes think of it as data science box imported from the future, boop, 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 and spits out answers. And then like what I think, or at least the person who wrote this cartoon, but I kind of agree with this, although I'll show it again at the end, is really data science is this collection of tools. Statistics is an important component. Software and ability to code is an important component. Having the infrastructure to support the work that you need to do is a really important component. A data scientist alone in a room with a laptop is probably not going to be all that successful at this point. And then the data sources, and I'll talk a lot about that. So before I get into my whole theory of sort of how science should be sort of more directly used in data science that's applied, I thought I would do a quick recap of my own career path, especially since I think there are a lot of students or sort of folks coming into the industry in the room that might be useful context. So now we've moved from the cartoons to the clip art portion of the presentation. So I started in a basic research environment. I had done physics as an undergrad. That's what I was most interested in. But when I went to grad school, I ended up in an interdisciplinary program that I got into because of my physics background. And then I rotated through a bunch of labs and ended up rotating through 3 systems neuroscience labs at Berkeley. And there, really, I was there for a PhD, so I went in thinking I would probably want to come out and do something in industry, but any of those of you who are either in grad school now or thinking of going or coming out, you really get sucked into that way of thinking, and it's good. You immerse yourself and you really get focused on these basic research questions and the sort of ideas and principles and ways of framing questions. I think it's really, really valuable. So I did that for 5 years or so. I did a short postdoc, and I remembered that I didn't want to stay in academia, which is what I thought on the way in. So then in 2008, I moved from basic science into what I would call applied science. So I got a job at a company called StarMine, which was basically looking at analyzing financial stock market data and coming up with sort of predictive analytics or predictive signals that investors could use to determine which stocks they might want to invest in. 2008, you might ask, well, interesting, for some of you who were around and remember 2008, this was a very interesting time to come out of academia and go into the workforce. I got really lucky on timing and on what type of position I got, because I got my job in May of 2008, and I think if I had waited until the end of that year, maybe I would still be in academia, I don't know. And also, I was looking at a lot of different types of firms. Actually, I remember it was in San Francisco at the time, so I remember I was looking at FICO, or the company that does the FICO credit scores, whatever they're called, and a bunch of different things. In San Francisco does not have a ton of sort of investment and quantitative finance type roles. So I ended up at a company that was not unbeknownst to me, in the process of being acquired by Reuters News and Financial Services, which was in the process then of merging with Thomson Financial. So it was an interesting time to go from basic science out into the workforce and join a startup that immediately got sucked up into a 50,000 person global company. I learned a lot, and I changed my ways of thinking about how to get work done there. So it was there for, I guess 5 years. Time flies. You realize this as you start to get old. You go back and like, oh, wow, yeah, that was a whole chunk. So I felt like this was interesting. I learned a lot about applying research in an industry context, or when someone's buying the output of my research. But I kind of missed that startup or small entrepreneurial feeling that you get either in a lab. Frankly, I really did have that in my grad school lab. It felt like a startup, like we're a little band trying to get something done. And so I missed that, so I wanted to go back into startup role. So worked for a startup here in Boston for the last 6 years, where really I was still doing research in data science and running a team where we were trying to analyze kind of again stock market predictions, but here we were doing it sort of one step removed. So this company called Quantopian, which is over in downtown Crossing, really looking at can you crowdsource investment ideas, and not just individual ideas, but actually systematic ideas. So can you get people online to write algorithmic trading strategies, and then can you harvest the output of those algorithmic trading strategies to design an investment strategy? It was hard, and we did do it, but it was very challenging, and I was ready for a change coming into the last year. So sort of on this seesaw of small entrepreneurial startup land, and then big company land, back and forth. In this summer, I moved to Fidelity Investment. So talk about moving from one end of the spectrum in terms of size and complexity and a number of folks that you're dealing with. And in fact, I've been doing, for any of you who are familiar with investing or financial research, Quantopian was running a market neutral strategy, which meant we had no view on how the stock market was going, fully systematic, being long and short the market at the same time. So I moved to Fidelity. Fidelity is a very large asset manager. You've probably heard of them. They have a lot of different lines of business, but they are not really a quant shop, and they think about the world in a much more discretionary way. So it's been a really interesting evolution to sort of go and see how they think about quantitative and applied data science inside that firm. All right, so now we're going to get back to kind of the construct, what I thought might be interesting to talk about for this audience. So it's funny because I would kind of sometimes be summarizing my background for people, and I'd say, well, I used to do basic research, and now I do applied research. And some people would be like, well, what was that basic though? And I'm like, no, it doesn't mean that it was like not useful. This is this concept that I think we all get very used to saying, and when you're in academia, you are used to this terminology. But I went back and was thinking, well, why do I think of it as two different things, and what are those quintessential definitions? Right, and the traditional definitions are basic science is pushing forward the boundaries of what we understand about the natural world, the world around us, ourselves. It may or may not have readily observable applications, and that's fine. Right? And then when we think about applied science, and today I thought I would talk just specifically about applied data science, we're really talking about something where those insights that you're generating, their value is if they can be sort of filtered through analysts and business users who have real domain expertise and create tangible business value. So these are two different things, but I think it's a disservice to separate them so strongly as they often are separated. And I think that there's a ton of value that can be had thinking about the overlap and the interaction and the sort of feedback loop that can be created either when you've got different teams talking to each other, or honestly, I think even within the same person, you can be thinking of skills that you have from basic or applied basic research and applying them and iterating at it. I think this line should be a lot more blurred. After I wrote this whole talk, at the end, I think maybe we'll share the slides or I'll at least show the link. I found an article someone had written that already summarized this much more elegantly. I think it was a Harvard professor, so I put that at the end. So what we thought we'd talk about today is really focused more on the data science side, and I wanted to sort of bring the applied and the industry perspective to this and sort of talk about how I've seen it work well and where I think a lot of the challenges are. Maybe that will be useful for you guys as you go forward. So let's recap. Right? Applied data science is, our goal is to generate insights that analysts and business users are going to be able to translate into business value. Now, the data scientist can also be an analyst or a business user. Those don't have to be separate people, and at startups they are often the same person. That's very powerful, but there are two different hats that you have to wear. So I thought I would talk a little bit about a couple of examples. So the first most important thing you need to remember if you become a data scientist inside of a company and they expect to be able to monetize your efforts is that you and they better both understand what the tangible business value that you expect to be delivered from the output of your work is. And you need to constantly be reevaluating whether you're well aligned to that. So what are some examples of tangible business value that can realistically be delivered through data science? I listed 3 here, which are very like retailer sort of customer facing. So increased engagement from users. I think we're all familiar with systems that do that really, really well. There are probably ethical implications to how well we're actually able to do that. But that is a business value that you can deliver with data science, right? What can I do to grease the skids to cause people in my user acquisition funnel to slip through that, to be engaged, to want to click? That's a very tangible business value. For usually sort of that's directed that, okay, now I'm advertising you, I'm selling something to you. So more directly said, you could also say a tangible business value is just increasing the sales of a product or service. That could be through more directly marketing that product or service to someone would be one example. One that I like that I think gets overlooked a lot is just increasing customer happiness. So I see a lot of examples where people are thinking, how can I use data science to trick people to buy my crappy product or use my crappy service? I'm not naming any names. And an example, I really not. There's so many. They're all the same thing. But what I'm thinking of with increased customer happiness are companies like Zappos, right? So if any of you have read or if you haven't, checked it out, Tony Sheave, how you pronounce his name, wrote this awesome book, The Guy That Started Zappos, and he became just fixated and focused on what can I do to cause my customers to be happy. And it turns out there's a lot of data science that you can apply to make your customers happy. That might be making faster delivery times, right? That might be streamlining your call center so that folks are able to get to a person. There could be non-data science tools you can use to increase customer happiness. What I like about that one is it's an intermediary between trying to just optimize on increasing the sales of a product or a service. Because if you're increasing customer happiness, you have a pretty good idea that happier customers are going to continue to buy your services. Whereas if you're just optimizing on sales or product engagement, that can be a very tactical short-term value. And if you're then not making that customer happy, you're probably going to end up with a churn problem where you might destroy goodwill. So those are some examples of ways you can think of tangible business value. I didn't put on this slide, but another category is sort of less sexy but maybe more impactful, which are behind the scenes improving operational efficiency and automating processes. That category is really the one that I see front and center in the financial services industry. Yeah. There we go. Okay, maybe it just went to sleep on me. So that automating processes and improving operational efficiency, I mentioned call centers, customer support. There was an example that I really liked, and actually I wasn't sure if I'm allowed to sort of steal slides from Marty Schaffis's presentation that he gave at Goldman. So at Goldman, the CTO of Goldman is a computer scientist. I think he did his grad work at Berkeley, and he spent 20 years basically overhauling all the back-end infrastructure and how data is stored at Goldman, and he made this lovely, elegant solution of just everybody using one centralized data repository allowed you to ask a bunch of business questions. And at one point, they looked at the equities trading portion of their business, and they figured out we can apply data science to automate basically trading cash equities. And he went into the office one day and he said, okay, well, great, we've come up with this model. Here, this grad student has done it, or this guy who was just a grad student. And now all of our traders can keep their jobs as long as they're better than this bot. And over the course of 5 or 6 years, they went from having 600 traders to 2 traders on that trading desk. But they went from having some small number of computer scientists to 200. So I think there's an interesting theme in when the tangible business value is improving operating efficiency or cutting costs. You can think about challenges where it is going to have implications on workforce. But you can also think about where it's changing the shape of what that workforce might look like. So that I didn't put it on the slide. I didn't have a nice little graphic for it, but that is a big one. Okay, so this one gets a little bit closer to being maybe fulfilling a little bit of the idea of the technical portion of the technical talk. So just as important as knowing, what is the purpose, what is the business value that this research is designed to unlock, is getting very, very tangible as early as you can about what is the form. Is it a number? What is the form of the insight that I'm going to deliver that's going to allow that business user, analyst, domain expert to create value? So here are a couple of examples. Next best action, these are also kind of, I've stuck with sort of sales channel-y kind of topics. Next best action would be something like saying, hey, I'm going to put this model in front of a sales force, and I'm going to be either telling them who to call out of a list of who they might need to call, or who to engage with, or what meeting to take, what conference to go to, what to do, and maybe even specifically what to talk about. So if you're thinking that what you want to create is a model that produces next best actions, you need to know that not only do you have data that might be predictive or informative about that process, you also need to have a menu of actions, right? So you're not just thinking, hey, who's going to buy this? You need to know that that analyst can have a list of their customer base, right? And it's a little subtle to explain, but if you're doing next best action, you not only need the sourcing data, but you need to know kind of what you're ranking or what your menu of possible actions that salesperson might be able to take. Is it a phone call? Is it reaching out in person? And you need to really kind of know what the implications. Is that next best action you're going to recommend, kind of like what's the risk associated with you being wrong about proposing that next best action? So if your problem is something like I'll take a problem that I saw inside of Fidelity, and I don't think this is proprietary or secret, I'll make it very general. So Fidelity has to think about, let's say a sales force somewhere inside of Fidelity has to think about, I've got a coverage universe of clients that I speak to, and on any given day I can call any of them, right? And so maybe I cover 100 customers. Who am I going to call in what order, right? So if your next best action is, hey, call Bob first, then if he doesn't answer, call George, then if he doesn't answer, call Jerry. If you resort those, or you sort those wrong, kind of worst case is you weren't that efficient. But you didn't do something really bad. Whereas, this is not bad, but I like the next best action idea of when, Amazon is sending, baby products to someone who doesn't, has someone in their household they didn't know was pregnant yet, right? That's like, okay, well, that was maybe the next best action, but maybe they didn't want that, or you have these other unintended downstream consequences. And you can probably think of your own examples of next best actions where if you're wrong, there's a big negative implication. So you really want to know if, as an example, is that what I'm going for? Product recommendation, maybe you could use my example there as a product recommendation. So there again, what is the suite of products that I might be trying to organize to figure out if I'm going to recommend? What is the downstream negative implications if I recommend the wrong product? Is it no big deal? Hey, it's slightly less efficient. Or is it bad or offensive, or I'm profiling you or something? Another one is probability of a purchase. Probability of a purchase is something I see people try to do a lot. It edges toward when I'm going to talk later about the things I think are most challenging. A probability is sort of a prediction about a thing that's going to happen in the future, right? These other two are not really, maybe you could say they're sort of predictions that you'll have a better outcome, but you're going to do this anyway, right? You're going to take some action or recommend some product, which one in what order your model's going to do. When you're forecasting a probability, you're starting to make predictions, and predictions are hard, especially about the future. As soon as you get into anything that's sort of prediction focused, you have a whole other suite of challenges that you're going to need to think about in terms of what your data set is, how it's time stamped, do you know what you knew at what time, you have point in time data. So that's a tricky category. All right, so we went through, do I understand the business value? Do I know what is the form of the insight I'm going to generate? And that one I think you get really specific on. And then this one is enormous. And again, those of you who have worked in industry settings are probably really familiar with this last piece, which is, okay, I mentioned that you're going to have to be part of a partnership probably, or a collaborative team where there are domain experts, there are business users, there are analysts, or maybe it's the person between your model and the customer. Is going to have to understand, and this is actually also true for the business leaders who might not be in the workflow, but there are going to be other folks at your company that need to understand how your model works. They need to be able to capitalize on the insights that you've generated. And they need to kind of trust what you've built. And this is where you start to get into topics you'll hear buzzwords around sort of, transparency or interpretability of models. That's important from an audit standpoint, from proving later, like there's a good reason that I proposed this action or gave this credit score, right, or whatever. But it's also really important from the standpoint of, if you could build the best, most predictive data science model in the world, if no one can understand it or trust it and they don't use it, then it's just a great predictive model sitting in the closet. And that happens all the time. I won't do a survey to ask people to raise their hands. I could probably have a better result of have you ever had a model that's really people trust and it works. This is a huge, huge, huge challenge. So what are some of the ways to think about getting a positive answer on this question? Does it make sense? That one seems like it doesn't need to be said. And yet, it does need to be said. So is there a common sense framework? This is where I will start to get into, I think there are skill sets that come from doing basic research that are really, really valuable on helping you on that. Does this make sense? So have I set up, my view is, there's a lot of value in bringing hypothesis-driven research thinking to business data science problems. And if you've come in with I'm trying to answer this question and prove or reject this particular hypothesis, your likelihood of having something come out that sort of is a result that does or doesn't make sense goes way up. Does it offer valuable insights, right? So I might be able to have a really good prediction that down the line I learn that prediction actually doesn't really drive user behavior or doesn't really drive sales, or the improvement I can make from that prediction isn't going to make that big of an impact. So you want to offer a valuable insight. And then, is it easy to use it? These are auto-generated little pictures that PowerPoint does for you now. PowerPoint is getting really fancy. I can't believe I'm making like a Microsoft product plug. It really is getting fancy. The new back to front sort thing too is kind of mind-blowing. And it picked this little shopping cart icon on the phone for is it easy to use? And I was like, that's just actually perfect. That's kind of what I need. Is there like a little shopping cart? Is there something super, super easy to use? Rolled in, and there wasn't a nice little picture for this. What I also wanted to say under easy to use is and maintain. So look, we come out of research. We are not in the business historically of building products or building processes that are designed to be run at scale many, many, many times or over and over and over again in the future, right? If you think back to that, what's basic research, just push the boundaries forward. We're often the kind of people who are like, all right, well, I pushed that boundary forward, I figured out that was possible. Next, what's the next most interesting thing I can go work on, right? On to the next thing. I've been very guilty of that. But if you deploy a model, you got to know that somebody's going to be able to use it, maintain it, and continue to operate it going forward. That one, I think, has sort of organizational design implications. So I've seen something work nicely at Fidelity where we've got a centralized pool of, we call it an AI Center of Excellence. So there's a centralized pool of data scientists who are building AI and machine learning models, but when they deploy a model into a business unit, there is a dedicated data scientist that lives inside that business unit who has been involved in the development of that model, understands how it works. Maybe couldn't have necessarily designed or built it wholly on their own, but they know how it works, they know where it's deployed, and they can sort of take ownership of it and then sort of do that care and feeding. So once you go from basic research into applied science, you got to start thinking about being able to have production processes that are maintainable in an ongoing fashion, as opposed to, I did it, I learned the thing, I'm ready to move on. As much as that's probably how a lot of us would rather just work. Okay, maybe that all sounds easy. If that all sounds easy, great. Glad that you're so enthusiastic about it. What are all the horrible, horrible things, right? The first three, at least, are data. So, again, if you work with data, love-hate relationship. You need data, you cannot do your work without it, but it is so horrible and miserable. The acquiring of it, the cleaning of it, the understanding what it is, it's never documented, you don't know what the fields mean. Some columns will have numbers and then letters. Or you'll find out 999 is the placeholder for there's no value here. You're like, that's crazy. Why would you put numbers, a specific random number to mean there is no number here? So data is the most horrifying problem, and you have to be really comfortable with that. It's true any field, whether you're in applied or basic. I think there are some specific categories to be thinking about with data. So number one is, can I get the data that I need? That's a little bit of a different category. Does the data exist, or can I get access to it that's going to solve my problem? And then one thing that I'm always amazed whenever I just come in and I'm trying to help someone evaluate or look at here's a model or a process where a result doesn't make sense. You guys will hopefully already know this, but just the very simple, people will be like, well, at this statistic or that statistic or the fit of my model, I'm like, yeah, did you count? Did you do count? mean, median, like you do basic descriptive statistics, like are there missing values, what have you got? So to me, the very first thing I usually ask people is, can we just look at a distribution of your data? We had an example, someone that I worked with at Quantopian had this side video game project that was hilarious. I got him to write a talk about it and presented at an investment thing. And his talk sort of went, I trained a computer to play this video game for me. I won't even go into why. Maybe some of you will be like, oh yeah, that sounds great. And he got all these garbage results because the video game involved feeding in a bunch of data about where a cursor was on a screen with XY coordinates. And he trained this model, which I think he deployed to Amazon Cloud or something, and gets garbage out, and he realized, oh, one of my points was an outlier and was off by 2 orders of magnitude. And what the downstream system then did was to round every single other data point to 0. So he had trained this whole big model on 0 and a million. And that took, this is a very smart guy. He's looking at my colleague who knows who he is. It took him a good while to figure that out, right? And in hindsight, thinking and knowing about those problems that can happen with data is important. So I already talked about this one a bit, but I think it bears repeating, because this is one of, maybe this is the second or sort of, in this case, fourth biggest problem I see. Effective communication and collaboration between the data scientist, the applied researcher, and the business users. So that's on expectation setting. That's on, again, do we both understand the business value we're trying to deliver? That's on, did we formalize and both decide it makes sense what the form of that insight is going to be? That's a huge, huge, huge challenge. I've seen it everywhere that I've ever worked. I was thinking, what's the sort of basic research science analog of that? And I think it's sort of communicating your science effectively to people that are outside of your lab. So it's the same type of challenge. It's different in the minutia, but being an excellent communicator is probably one of the strongest skills that you could bring into a data science job in industry. I mentioned this. Predictions are really, really hard. So some types of data science models you can think about building in industry don't have to be all that predictive. Or if they do, the penalty for them being not so accurate is very low. Those are the great types of models to build. The really scary, dangerous types of models to build. So I was working in quantitative finance for a while, right? And if you build a model that says, invest a lot of money in this stock one way or another for a few days and you're really, really wrong, that's a very painful way to be wrong. Now, in industries like that, you develop techniques to work around it. So in the quant finance land, what you do is you say, ideally, my best predictions have a 52% chance of being right. Well, what are you going to do? How are you going to make money with that? Or you're going to make lots and lots of little uncorrelated bets would be your idea. So you design then the downstream way that you implement and try to translate that model into value in such a way as to be okay with the fact that your probability of being correct is barely above chance. So it's important to think about if it's a predictive model, there's a whole host of things you got to be really careful about. This is a huge one in industry. This is a little bit, no offense to academics, part of what drove me out of academia. I like that fast turnover time. I did something, I found something out, I deployed it, we're using it, it's working, and now I'm on to the next thing. That's huge in industry. So the time to delivering that insight that you have jointly decided with the business unit is of value, that time is super critical. Every day or month that's ticking by that business value is not delivered, everyone's getting bored. And moving on, the world is changing, no one cares anymore. So if you could deliver a model, I'll oversimplify, but there's this 80-20 principle. If you can go and iterate and show a little bit of value and then build on that and a little bit of value and build on that, you're going to generate a lot more goodwill than if you go away and work in isolation for a year in your lab, if anyone will let you do that in industry. Some places will, and it usually is bad. So pace over perfection, that is sort of actually that is a Fidelity aspirational core value, it is what you're looking for. And then this last one, I see also all the time. So sort of this constant reassessing of what am I optimizing on here? And when we think about building models, we're usually like, yeah, I'm optimizing on whatever the fit statistic is or the accuracy. It's a number, I'll know what it is, I'll keep running it. Yeah, but does that matter, right? If the difference between getting a little bit of a better fit model is going to be another 6 months and no one's going to care about your project anymore, and actually it only makes it 6% more valuable, does that matter? And so constantly looking and checking, is it worth it for me to improve the quality of this model, or should I just ship it and move on to the next thing? So quickly recapping, these are like 6 basic tenets of science. And I found this somewhere where I was like, how do I explain like the concepts? And actually, as I looked at these, which I kind of just randomly stole off the internet, I was like, yeah, this is what I'm always trying to get across when I'm talking to folks in industry. I won't go through all of them. You guys understand these principles. Extraordinary claims require extraordinary evidence. Be very skeptical. Sometimes people, again, think the magic data science hat can't be wrong. It can be. Is it falsifiable? Like, can you tell a counterexample and sort of check that your model is making any sense? Occam's razor or parsimony principle. This one is become maybe the most important in the age of machine learning and AI-driven models. The number of times that I've had someone be like, hey, look at how great this fancy model is. I'm like, well, so what % better is it than like this simple model, or than a guess, or than some alternative? So I think it's really important if you're a data scientist to be thinking about what are the unquantified or difficult to measure costs and risks associated with increasing model complexity. And to me, in a business setting, that's what really makes this parsimony principle or deploying or using the simplest possible model really, really, really important. And then, ruling out rival hypotheses. So just doing hypothesis-driven research to really try to keep yourself honest, and knowing when you have two correlated events that are not causal to each other. That one's extremely challenging. And to me, I think, that one is really, really, really hard to solve for, but it's something that if you're thinking about how to check your model against benchmarks or standards or existing things you already know, that one kind of is a little helpful in the does it make sense category. But none of these are necessarily easy to solve for, but at least if you're in an industry setting, I would tell you, don't abandon thinking about these principles as you're doing your work. They still matter a lot and they can help you do better work. So I think that's all I wanted to cover. I wanted to show my slide again and sort of make a pitch that I think data science is still real science, and the more that we pull from work that we've done previously or in other areas of basic science forward into applied data science, the better off we are. So thank you.
We'll take some questions now. I'm glad that we've all learned or heard that data is miserable, but we also got a really good plug-in for Microsoft PowerPoint, so well played. Good thing we're not at Apple headquarters today. So does somebody have a question? Okay, great.
Well, thank you so much for the great talk. I come from the operation analytics, but also financial service, so I can't fathom how much accurate it is. Sometimes it's really, really comical to actually see that somebody is actually sharing the same experience. The questions that I have for you, and I don't hear a lot of people in the industry is actually talking about this, is ethics, especially in operation research. I would give you an example. Say, for example, I built a decisions model, right, that optimized on efficiency for a call center. And my model suggests that, well, you can achieve the same efficiency or even higher, even if you have an 80% of your capacity. Well, what does that mean? Are you going to go ahead and just, have a massive layoff of 20% of the people in a call center? So, as from your background, how do you go about and incorporate and think about ethics when you're actually building out a model or building out a decision or formulating a strategy? Thank you.
Sure. So I think everyone heard the question, this whole concept of ethical implications of algorithms and data science. To me, it is not that there aren't really new ethical implications. It's just that we've built a lot of tools to take biases and existing unethical decisions that could be made slowly and do them faster in scale. So I don't think these are new questions of what if I find out that I can, fire half my workforce and still run my company. I think what's interesting is you now take a bunch of scientists and make them confront the fact that they're working in that process and they're sort of in that loop. So I think as a data scientist, what you can do is you've got to address those questions or put your thoughts or views forward in that what is the business value part and the what insights are we creating part, and not so much in the model part, right? So I think it's interesting when people sort of say, oh, well, as a result of having done all this work, now I've created this ethical implication. Well, no, you were going to create it from the start if you were successful in your work, right? I mean, you're always looking for, again, like I mentioned, if I'm looking to optimize user engagement and I do that really, really, really well, that's probably has negative externalities if I'm just trying to like keep somebody on their phone all day. So to me, I think it's not, the place for that conversation is not necessarily in the data science, it's right at the very beginning and the what are we doing here problem. So yes, I think those problems exist. I think we're talking about them in data science because machine learning and AI is taking what people can do well but slowly and doing it quickly and parallelizable. So it just amplifies the same problems that were already there. I don't have a great easy answer for you rather than to say, I think one thing not to do is to wait and embed that conversation in sort of, well, here this algorithm is biased or this answer is, it's the machine learning piece. It's probably in the question formulation up front. And well, what were the acceptable range of outcomes you wanted? You're checking how efficient to make your call center. How acceptable, are you looking to fire your people in your call center? You could either build a model that does it or just do it and check other work. It's up front, is my view. It's not really in the data science piece.
So I was really interested in potential business outcomes that you talked about, which are great from first rates, especially the customer happiness. I'm curious how you think about measuring that, because that feels like the hardest to measure.
I think that's really hard to measure. So I've only been at Fidelity for about 6 months and I'm in labs. I'm not working in the personal investing side, so I'm not wildly familiar with how they do it. A way that people try to do it is constantly serve up for little smiley face feedback surveys. I'm not really that excited about that. So what I think is tricky is, you can measure whether people have brand loyalty. You can measure whether they continue to use your service. You can kind of infer that you think that they're happy. Proving that they're really happier is kind of challenging, right? It's actually, I don't have a great answer. It's something I've been thinking about a bunch, which is we have got all this instrumentation and sort of analytics side of things, and what could we borrow from either behavioral finance or behavioral psychology to start to think where's the emotional component of this and how do we measure it? I don't think it's that easy. I think there's some kind of creepy things that are coming to be available in photo and video recognition of people. So I know there are models where people are applying to conference call transcripts. So if you're reporting earnings for a company, you've got some folks who are describing the financial results of the company, and what we used to do in the dark ages is just digitize all that text and analyze it, right, in real time. And now people are feeding the voice prints through analysis to try to say, well, did that CFO sound nervous? Because you can't see them. It's not Zoom anymore. It's not. They don't Skype or you don't see these people. So I don't know. I think there are ways you could think about really trying to get really hyper specific on happiness. The ways I know are surveys, asking for responses, processing so this is the whole influencer and social media part of things, looking and saying, being responsive. So are people saying on Twitter or Facebook or Instagram that they like your products? I don't know how sophisticated it's getting, but you either got to look at, you get to either ask, infer from behind buying decisions, or go get data that people are already sharing about their preferences or their feelings about your products or services and try to mine those. Those are the sort of 3 ways I think you can do it.
Thanks so much for your talk. One of the things that I think you described as a problem is really this differentiation maybe of the data scientist role. Companies hire data scientists and want them to do everything, and this will be not in a startup environment, right? Bigger companies expect you to do infrastructure and this sort of thing. So you think a lot of this could be mitigated better by companies essentially knowing the difference between a systems architect, a data scientist, a machine learning engineer, and business intelligence?
Yes, I think it's a huge challenge. It's not that it gets better or worse definitely at a bigger or smaller firm. The smaller you are, the less you have the ability to bring, sort of have all of those layers. I think it's I think there are companies that have figured that out reasonably well, and those people are going ahead faster. So if you're able to say, hey, key business decision makers understand that there needs to be infrastructure and that there are different roles, those companies are doing really well. And then you see companies who don't know how to figure that out, and what they're doing is saying, oh geez, why can't I seem to catch up on, leveraging this internal data that I have? And so they're starting to say, well, maybe there's a vendor that can solve this for me, right? And whether they think there is or there isn't, there's many vendors who are cropping up saying, I can solve that for you. So, that's tricky, because I think that companies who don't have the expertise are going to look for a vendor solution to that problem you referenced of like really you need 3 or 4 roles to support up to actually having like a deployed model. And so if you don't know that, I think people are sometimes inclined to say, well, I don't need those 3 or 4 people if I buy this vendor solution, then I can just plug the data scientist in on top of that. Some places maybe that's worked. I have not seen that really work. I think the challenge of saying, geez, how do I get access to the data? That's the worst one I've seen, although all the problems that you mentioned. So I think that's basically going to be a opportunity for competitive advantage for companies who have figured that out and are good at that and understand that problem.
All right, thank you so much for